Good day, I am Andrea Bacarisa.
And I'm Manansala, and we are here to discuss the principles of mathematical induction. Are you ready? 1, 2, 3. So, the principles of mathematical induction. First rule, P sub n sub 0 is true when n is equals to n sub 0. So this rule always applies. Wow. Next,
If pk is true for some integer, k
is greater than or equal to n sub 0, then p times the quantity of k plus 1 is true.
if n is equal to k is true, then n equal
K
k
plus 1
is
is
true
always true.
as well.
So, let's proceed to our examples. Example number 1. Using mathematical induction, prove that the summation of 1 plus 2 plus 3 plus dot 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 dot
And
dot
so on.
plus n is equals to n times the quantity of n plus 1 divided by 2.
So the first step is we have to let n be equal to 1. So we will substitute the n to 1. So it will be 1 times 1 plus 1 over 2 is equal to 2 over 2, which is
1.
both equal to 1.
So, yes, our n is equal to 1. And that states that this substitution that happened is correct.
Proven.
Yes. So, next step, let n be k. So, we have to substitute the letter k from the letter n's in the equation. So, k times the quantity of k plus 1 over 2 is equals to the summation of 1 plus 2 plus 3 and so on until k. So, the last step that we have to do is that prove that k plus 1 can be a value of n. Knowing that k plus 1 times the quantity of k plus 1 over 2 is equals to the summation of that. So, we have to prove that this is true. So, we have to use the equation with regards to the k. First k. So, here, k times the quantity of k plus 1 over 2 plus the quantity of k plus 1. So,
We will multiply
Two.
this to get to
put
put this together. Yeah. So it will be equal to k times k plus 1 over 2 plus 2
times the quantity of k
K
plus
plus
1
1
over
over
2.
2.
Then we will have the quadratic equation here, k squared plus 3k plus
Plus
2
2
over
over
2.
2.
Then we have to factor that. So the factors are k plus 1 and k plus 2. So k plus 1 times the quantity of k plus 2 over 2 is equals to
K plus
this.
1.
And we just have to arrange this k plus 2 to get that k plus 1 plus 1. So we have here k plus 1 times the quantity of k plus 1 over 2.
So we
So,
have proven that this is equal to this. Yeah.
So, we have used the mathematical induction. We have another example. Pause. Good. So, another example. Summation of n is equals to a sub 1 times the quantity of 1 minus r raised to n over 1 minus r. So, step 1.
Let n be equal to 1. So we will
Equate n to 1.
yeah. So it will be s sub 1 is equal to a sub 1 times 1 minus r over 1 minus r. So this 1 will be cancelled.
Because
So,
it's the same value.
yeah. So we will get a sub 1 is equal to a sub 1. Therefore, it is proven.
Yes, it is proven that S sub 1 is equals to A sub 1 is equals to A sub 1. Then next step is that let n be k. So S sub k is equals to A sub 1 times 1 minus r raised to k over 1 minus r. Then, we have to prove that S sub k plus 1 is equals to A sub 1 times the quantity of 1 minus r raised to k plus 1 over 1 minus r. Knowing that k is greater than or equal to 1. So, the summation of S sub k plus 1 is equals to S sub k plus A sub k plus 1. Then, we have here the equation in S sub k. So, we will use that and then add A sub k plus 1, which will be A sub 1 times the quantity of 1 minus r raised to k over 1 minus r plus A sub 1 times r raised to k. Then, we will have to multiply 1 minus r to put it together.
Wow.
So,
Yeah.
A sub 1 times the quantity of 1 minus r raised to k plus A sub 1 times r raised to k times the quantity of 1 minus r all over 1 minus r. So, we will have this.
And this.
Yeah, please read.
Yeah. We will have A sub 1 times 1 minus r raised to k plus r raised to k minus r raised to k plus 1 over 1 minus r.
So, we will have this. A sub 1 times the quantity of 1 minus r plus k plus 1 over 1 minus r. Since both of these r raised to k will be cancelled because of its opposite signs. So, we have proven that this one is the same as what we have to prove is.
Yeah.
So, let's move on to divisibility.
Divisibility statements.
Okay. So, in this divisibility statements, we are using also the mathematical induction just to prove that the divisibility form or the divisibility statement is true. So, example number 3.
Use mathematical induction to prove that for every integer n, for example, 7 raised to n minus 1 is divisible by 6. So, the first step is to let n be 1. So, if we raise 7 to 1, we will minus 1 is equal to 6. So, therefore, it is divisible by 6. We have proven that it is divisible by 6.
Yes. So, the next step is that you should let n be k. And it will always be equal to this first equation. So, we also have proven there that 7 raised to k minus 1 is divisible by 6. Now, we have to show that 7 raised to k plus 1 minus 1 is divisible by 6, given that k is greater than or equal to 1. So, 7k plus 1, 7 raised to k plus 1 minus 1 is equal to 7 times 7k minus 1. Then, we will have this equation when we are going to expand this equation. So, 6 times 7 raised to k plus 7 raised to k minus 1 is equals to 7 raised to k plus 1 minus 1. So, we have here that we have the hypothesis that once we multiply 6 to an integer, an unknown integer, then it is divisible by 6 since we have multiplied it with 6. Then this one, 7 raised to k minus 1, is proven here, right here. So, when we add here, the sum of this, 7 raised to k plus 1 minus 1, will be divisible by 6 as well. So, we have used there the mathematical induction. But, we have more examples. Just wait. So, this is our fourth example.
3 raised to n minus 1 is divisible by 6. Step 1, let
By 2,
by 2.
rather.
Sorry. Let n be equal to 1. 3 raised to 1 minus 1 is equal to 2. Therefore, it is divisible by 2. So, let's step 2, let n be k.
Then we will have 3 raised to k minus 1, which is divisible by 2, proven in the first equation. Then we have to prove that 3 raised to k plus 1 minus 1 is divisible by 2 given that k is greater than or equal to 1. 3 raised to k plus 1 minus 1 is equals to 3 times 3 raised to k minus 1. Sorry,
Minus 1.
minus 1. So, we have here the same as what we have done a while
The
ago. So, 2 times 3 raised to k plus 3 raised to k minus 1. Then, this is proven that it is divisible by 2 since this one, what?
Is multiplied
Yes,
by 2.
is multiplied by 2. Just like what we have said in the first hypothesis. So, then here, 3 raised to k minus 1 is proven here. So, the summation of them, or the sum of them, is equals to 3 raised to k plus 1 minus 1 is proven that it is divisible by 2. So, we should remember that in mathematical induction, we have 3 steps. First,
Let n
be 1.
yeah. Be
Then,
1.
if it is proven that the value of n is equals to 1, then that is proven already. Then we have the next step that we should remember. So let n be k, which is proven in the first step. Then we have the last step to prove that n is greater than or equal to 1. We have to equate it to k plus 1. So that are the things that we have.
should remember.
Yes, we should remember. That's all.
Thank you.